Bonding machine from Finetech. The equipment's made in Germany, and there's I come from the U.S. I'm from New Hampshire. We have an office in Arizona also. There's probably I think like 15 of us that support the U.S. sales and service and applications. So this model machine here is called the Lambda, and basically this machine can place to a 0.5 micron accuracy. Okay, so we'll just kind of go through some of the modules on the machine. Just we won't go into real depth on that. We're just going to go through to try to familiarize you guys with the parts and things like that. And then what we'll do is we'll go through, show you how you would set up the machine to actually do a process, and then we'll go from there. So, all right. So basically, you have this box here is a place of control box, and this box basically turns your power on and off for the machine. We have lighting adjustments here that you can adjust for your lighting. You have a vacuum status here, and basically right now there is a die up on top on the head, and this is what we refer to as the head, the placement arm. Okay. So there's a die up on there right now, and basically the green is solid, so that's indicating that there's something on the arm. If this was flashing green, that would mean that there's vacuum present, but there's nothing there. And when it's flashing amber, that means the vacuum is off. Okay. And then this box here is for the chip contact heating. So basically all of our heated tools, we call this the module that controls the temperature and the heating for it is called the CCH box, chip contact heating. And then down below over here we have another box, and that's for the heater plate here. So that box controls the temperature profiles and everything for the heater plate. The heater plate is 50 by 50 millimeters. If you had applications where you had to have a bigger heated surface, we also make 100 by 100 millimeter heater plates. So this heater plate here, the way that it's heated up is there's 4 halogen bulbs underneath, and if one of the bulbs ever went out, you would just take this cover off and change the bulbs. All right, so, and then over here we have a dispensing setup here. So we have a dispense, so if you had to dispense any materials onto the board to bond, conductive adhesives, UV material, so this machine has a dispenser integrated with the machine. Let's see, so this right here is our optic tower. And basically it moves back and forth. Whenever you move this tower, you want to use this handle and just push it all the way, and then you can bring it back. On top of the optic tower we have a Y shifter, so if you had parts that were bigger than the field of view and you zoomed in and you needed to see just a little bit more, this kind of cheats in the Y direction a little bit for you for the optics. Also, we have the zoom here, so you can zoom in and all the way out. This camera here is a process camera, and basically that camera looks from the side. So when you place, or when the arm is down and the process actually is going, you can take videos and things like that, so you can see. If you were doing like a gold-to-gold bond, at one point you'll see the die drop down, and so you can take videos, you can take still pictures and all those kinds of things. And we have, same thing, we have a zoom, and then out here, and then on the end we have a focus. And you can also adjust left to right, and you can move the camera up and down.
So this is a recording coming from you need to attach something, or if I do a video recording,
Yeah.
Is it record to the PC or recording to something?
It records to the PC.
Oh, okay.
But if you wanted, in the setup of the machine, you can go and have all your pictures, your recipes, files. You know, if you connect it up to a network, you have them all just go to a certain, so you can designate where you'd want the videos and all that kind of thing to go. But they would be stored locally on the PC. All right. So this right here is the table. You have a foot pedal down here, and basically you push and hold the foot pedal down, and it floats like an air hockey table. Okay. In the center of the table over here, there's a magnet and there's a bearing. So basically what happens when you release the foot pedal, the magnet holds the table down, and then you have a core state of rotation. Okay, so we bring this over, and we let it down, and then we have a core state of rotation. And you can see that that's holding us down pretty good there. And then up on the head we have another, let's see. We have another theta rotation, a fine theta rotation up on the head. All right. The table has X and Y micrometers to make your adjustments, and it has a Z height. So that we'll get into that a little bit later. So clamping parts into the rails. Normally you would be clamping the heater plate. So basically all it is I usually line the edge of the heater plate up to this edge over here. And then you have this push button here that when you release it, it locks the rail into place. When you push it, it allows you to move it. Okay? So you bring that up to the rails, and then I usually squeeze from the top and make sure that it's really tight in there and it's not moving around. Okay? And when you go to take the heater plate out, because of the way that the rails are designed, it kind of wedges in there. So sometimes it's a little, you know, you have to use a little bit of force to undo it. So if you found that you weren't going to use a heater plate, and say that substrate that you had, and that you wanted to, that flex circuit, and you didn't need the heat from the bottom, what you could do is you could make up a plate, and you can make a plate that has vacuum channels that'll hold it down where you want, and you could just pipe in, you know, your own vacuum to that plate. And if you do make the plate, I'll give that back to you. This is, you can use this calibration plate that's with the machine here, and this is what you'd want to do, is make the edge, copy this edge here the way that it's made if you were making a plate that you would put into the machine. Okay, so basically on this plate there's a thick side and a thin side. This machine uses the thick. So same thing here, we put that in and just clamp it down. So that's how the table, and basically right now this table is tipped forward, so that if I just push the pedal and I wasn't hanging onto the table, it goes forward instead of coming this way. Okay, so it's out of level on purpose. Okay. So the way that the system works is we have a beam splitter here. Okay, and basically depending on the amount of light that we put to the head or the target, that determines how much we see. This is very, very sensitive, so it's one of those things you don't want to bang into it, or things like that, because basically this is just this block here that holds that beam splitter. It is basically just some silicone that holds it onto that plate. So if this was to get dirty, when you go to clean it, a lot of care is recommended, so that you're not pushing pressure on it or anything. But the environment that you're in here, I would have to say that, it's probably going to be all right. If it was just dust or something that was on it, I would recommend like some air at a lower pressure just to blow the dust away, that'd be the best way to do it instead of trying to get in there with something to clean, unless someone touched it and there was a smudge on there or something and you had to get it off.
Do you have any specific spray for that?
Yeah, you would use, like what you use for microscopes to clean, optics, anything that is recommended to clean optics and things.
I mean, I have the compressed air can. Maybe I can use this can.
Yeah,
So
that would be the best
yeah.
thing is if it's just dust or something that you see.
Like the small hooter, that's rubber hooters, small ones. You press them, they let out air.
Yeah, that could work too. So this whole optic tower moves from left to right, and what you have is you have 35 millimeters of travel in X. So if you had a larger substrate, and you can see from 0 all the way up to 35 millimeters. When this, right now, if I have this in this home position, and I try to bring my arm down, it won't let me because there's a safety interlock that locks the arm so we don't bring it down and smash into one of the lenses. Okay, so when we push this all the way, that releases the safety and allows us to bring our arm down. Okay, this right here is the force that you can apply during your process, and on this side of the arm, there's a scale that goes from, I believe it's 0.3 newtons all the way up to 20. And to make your adjustment, you just bring this up and line it up. I have it lined up with 10, so right now there's 10 newtons of force being applied. So when you bring this arm down, you bring it down to this position, and that's what we call our safety position. And then there's this arm over here, which is called the lower arm position, and we refer to it as the lap arm. So basically this is where you'd bring the arm down, and you can see with my sat camera here, I can see and let's adjust that. We can see this coming all the way down. Okay, well it's not touching right now because we're not set at our 0. All right, but
so that's the head moving up and down?
yeah, so there's the glass slide that's being held on there right now. So this is, that's the head.
The forces depends on the thickness of the die, or
No, force depends on your process.
okay.
So if you were just doing say that flex circuit, you were just soldering something that had like lead-free solder or micro BGA or something, or just some micro bumps or something. Normally that type of application, you would just heat from the bottom and let it kind of reflow on its own. If you were doing a gold to gold bond, that requires heat from top and bottom and force. And basically, let's move this back down here. I put in right here, where is it? Process guidelines. So here's some gold to gold bonding. It just kind of goes through the different types of bonding, and it kind of gives you a little bit of recommendations, starting points, what you should be aware of, temperatures and force, and like when you do gold to gold bonding, I don't remember. Yeah, let's see. It's 6. Okay, so basically, if you're doing gold to gold bonding, it says 50 to 75 grams per bump. So basically, depending on the amount of bumps you have, would dictate how much force you're going to use during the process. And gold to gold bonding, basically, what you're going to do is you're going to come up really fast, as fast as you can, and once you get to where it bonds, that should only be 5 seconds, 3 to 5 seconds. Basically what you want to do is come up really fast with your heat. You're going to do your bond, and then you get down, you cool off as fast as you can, because if you stay up there too long, then all of a sudden now you're going to have intermetallics and all kinds of other issues that could crop up from being at that higher temperature for too long once the bond is made.
So this bonding is for solid to solid. Means is it, for example, because it's temperature based, just I'm wondering if one of those, let's say for example the dies from polymer, it could be with this actually be bonded on the surface by controlling probably the temperature or something.
Yes, yeah.
But the temperature can be very low. So
Yes, yeah, you can adjust. And you can, all these processes too, you don't have to, that's why before I was saying, like, some people are just heating from the bottom, they're not heating from the top. Some people are just heating from the top, and they just have, so the heater plate, you can have that just as your kind of holder for your substrate that you're bonding to, and not have to have any heat. You can have it, when you set up your process, you don't have to have it in there for heating and stuff. You can just have it there. Basically, it's just kind of holding your substrate and for your bonding purposes. So this is on the desktop here. Some recommendations. It's good starting points and tips to depending on the bonding that you use.
I asked a question for conductive groove. So you just need to apply the pressure, right?
Right.
Okay.
Yeah.
So that does not require any heat.
That's right. Well, I mean, there might be a low level of heat, maybe for a cure. I mean, all these products have, data sheets, recommended processes for you. They're going to tell you, how long you should be at a certain temperature and, that kind of thing. So.
But how about this dispenser? So the dispenser, once the dispense, do you have a pipe going?
Yeah.
If there is still things remain inside, how are you going to clean it? To, let's say I change something. Because I see this is a whole
different material.
Different materials, right? How
do you change this up?
Is this? Is this one? Yeah. Okay.
So
Okay.
basically,
Dispenser is there.
Dispenser is there. Oh, okay.
yeah.
Okay.
So basically, it's like any dispenser.
Okay.
right?
Okay. Okay.
just
This a pressure, right?
Yeah. So
Okay.
then basically, you take that and then you put this back.
Okay. Okay. Good.
So this is dispensing some chemical liquid.
Well, this right here is just hand soap.
No, yeah.
So I just put some hand soap in there to test it out. So that's what I normally do when I go somewhere. So basically, we'll get into that a little bit more as we go along.
But
Okay?
normally you would have what, paste, gold paste or something?
Yeah, you can, whatever materials you want to do. There's this, limited kit here of nozzles and, stuff. So basically, depending on your material, like materials that are very viscous, this is a nozzle that works better, because what happens is if you try to put something that's really viscous through a really tiny needle for this length, it just doesn't work out so well. Whereas this has a tiny hole at the end, but it's bigger. So as far as the dispensing and things like that, and the needles and all that stuff, and the cartridges, that's all stuff that you don't have to go directly through Finetech. You can go through like EMC and some of these other dispensing companies that do dispensing and stuff. They'll have different style plungers. For dispensing and things like that.
So these are not reusable, like they can clean each.
Well, yeah, I mean, normally, you throw it away. Your materials sometimes, depending on, even your materials, you don't want, some material, it's kind of like you use it that day and you don't, some of it has to be stored and refrigerated and all.
Right.
And some materials, depending on what it is, goes bad after a certain time too. Once it's
So all this also depending to the pressure. So I'm wondering just how much is this, because if it's very viscous and the needle is small, then it will be actually
right. We in the program you can adjust your pressure and time and all that kind of stuff. So it's and basically this dispenser is a time pressure dispenser. It's not like some of the auger types and things like that. So it's. All right, so whenever we bring this arm down, we always want to make sure that this arm is in the up position, okay? And we always use this arm to finish placing, okay? So this gives us nice precision, accurately come down in place, okay? So, and then once we bring that all the way up, then we bring this and we finish, and then we would bring our optic tower back to where it was. All right, so the placement head, yeah, we won't get into that. All right, so I'm just gonna shut, so right now, this is the main power button for the machine, and it's not letting me shut the machine off because it senses that there's something up on the head. So it's it's a safety. So if you ever try to shut this off and it's not shutting it off, it's probably because there's still something on the head. So that way, it's not gonna just drop your part, and sometimes those parts can become rather. So what I'm gonna do is I'm just gonna shut this off. And okay, so it's Windows 10 like any other system. So basically when you start the machine up, there's the manual in here. Yeah, why don't we do this right out of the gate here. Okay, so the way that our system works is we have a fixed focal height here to set our zero, okay? And so basically, because we're on a pivot, when we're set at zero and we come down, there is a dimension that is for perfect square, okay? And that dimension is 22 millimeters, okay? So this is just kind of showing what we call, this is what we've patented on our machine, it's functional square. So the distance from the beam splitter to zero to our pivot point up to our head is all the same dimension, okay? And as we come down, so what happens now is, so we're going to worry about 22. This tool is made for a 0.3 die, okay? So if I was to use a 1 millimeter die, it's not going to work because my 22 is not going to be right. So whenever we make up a tool, we make up, so this, if we measured from this point here to the face of the tool, it would be 21.7 millimeters. And then when you add the 0.3, now you get your 22. That's very critical because if you're trying to place with precision, if you're not coming down flat or square, it's going to hit on the heel or the toe first, and when you release it, it's just going to kind of free fall, and you lose your alignment. Okay.
So what about the width of the like a substrate? So
the substrate, what we would do, we'll get into that after. Let me just kind of go through this first. Okay, so normally if we have a die and it's the same size pretty much, and we're going to be using various thicknesses, what we would recommend is that you buy your tool for the thickest dimension. And normally we recommend that you buy it for 1 millimeter. Chances of it being thicker than 1 millimeter is pretty slim. So what we would do is, if I had a tool that was made for 1 millimeter thick die, and I was using a 0.5 millimeter die, what I would do is I'd go through these spacers, I'd find the 0.5 millimeter spacer, I'd take it out, and I put it on my tool, and now I'm going to be at my exact 22 millimeter dimension, okay? So that's why whenever you buy a tool, it's always better to buy it for a thicker die, because that way you can always add spacers. So this tool right now is for a 0.3 die, so basically, I can go lower, thinner, but I can't go thicker with this. So this tool doesn't have a lot of flexibility. But if 0.3 is pretty much what you're using across the board, then fine, don't worry about it. But just to let you know, so this 22 millimeter distance is very, very critical. Okay, so it's showing you how you would do that.
If by mistake any students use some thicker things, it will damage the die.
No, it won't damage anything. It's just not going to place. If they're trying to place accurately, then it won't place right. What'll happen too is, because now when you're coming down to put some force, you may find that, say you had bumps on one side, maybe, crushed down, and then the other side, it's not bonding at all, because it's not putting force equally across the whole surface of the die. All right, so these spacers come in a kit, And I'm just gonna leave this one here with you guys so that you know. So with your machine, this comes with your machine as the, for our calibration. This can also be used as the, as a placing, if you needed to place something without heat or anything, so you can use this. Also on the, let's see, where, oh, I put it in, so here's the dimensions of this calibration nozzle. So if you wanted to make, if you have access to a really good machine shop or something, you can make up your own unheated tools. And here's the specifications right there. So basically that's showing you how this was made. So basically, you would just make your tool accordingly to, for the heights and stuff that you need.
What is the main difference between heated and non-heated tool? Like,
this is just placing. That's all. Yeah, it's a heated tool is this. So this costs about almost can be like I forget. It's $2,500 to $2,600 probably. Yeah. Versus
$20 maybe.
no. Well, this one. No, I mean if you bought it from Finetech. This is probably going to be like $700 or something dollars, So, so you can see that there's a big difference. So if you find if you have access to a good machine shop or something, you can have them make up tooling for you But when it comes to the heated, there's a heater in here, and it's just all this other stuff going on. So that's something that unfortunately you'd have to go through Finetech.
So one is like a heated one is more better for the joints?
Nope, it's all dependent on your process. So if you need the heat from the top and the bottom,
Okay.
right, then you need a heated tool, right? And if you don't heat, you're just heating from the bottom, or you're just placing something down into an epoxy or a UV cure or something, you just put it down and let go of it and cure it, or then you don't need. But you can use this to place also. You don't have to use this to heat, okay? So you can use this for both. But if you were doing, epoxy or something, you just have to be really careful that you don't get stuff on the surface there, and then all of a sudden now this, the planarity of this is not, good. We make tooling with gimbal faces. So when you get into dies, say 5x5 and go up, say you get something that's 10x10. Now the planarity of this coming down to your substrate is critical. So we have tools that have gimbals, so that when it comes down, it gimbals and it holds it flat, and then you come down and it'll just flatten itself out to.
If the UV is used, then the curing agent should be injected from this nozzle, yes?
If we use
If you
UV
use the
cure?
UV, yeah, because you need that curing agent as well.
Well, yeah, you would dispense the
From
UV
here.
cure, UV material from here. You dispense it down to your substrate and then place your part.
And the UV is emitted from the top?
Well, UV. So then you can use UV, but you'd have to have your own UV curing system with, to do that type of thing. I've seen some people, they'll place it and then they'll bring it somewhere else and then cure it, or they have a UV cure station with the flexible light cables, and they just kind of, I've seen people just hold it,
Oh, the machine still doesn't have...
It does not have UV light or anything like that, but it has the potential to dispense those types of materials. We do have options for that, but this machine doesn't have that option.
So that option also is for the transparent substrate, because anyway, the curing agent is under use of the dye, and the UV is coming from anywhere, it should go through that actual substrate. So, I mean, that's a quite different machine actually.
Yeah.
Yes.
And
Okay.
regarding the heating profile, so we can adjust the heating profile, how much heat is we require from the
Yes.
settings.
Yes. Yeah. Okay. All right. Let's see what else. Okay. This can get a little confusing, but so if you're working with a bigger die, sometimes what happens is our field of view is, you know, when you zoom in all the way, it's pretty small. I don't remember, sorry, off the top of my head what it is, but so what we do is if you had, this is like an example of a 10 by 10 die, and basically if you can see the corner, you can make your alignment